Hi guys, so today I'm going to go over free radical substitution mechanism for alkanes. So the first thing you need to remember is that alkanes are generally unreactive. This is because they have strong C2C, C2H bonds, and they are non-polar. So this reaction normally needs harsher conditions. So we're going to look at free radical substitution. And this involves going from an alkane to a halogen alkane using UV light. So this is a type of photochemical reaction. So in this case, photochemical reaction refers to any reaction where you've got UV light acting as your catalyst, or providing the activation energy for this reaction. So another thing you need to remember as well is the types of bond fission that occurs in this case. So in my previous video on electrophilic addition, I went through this. So for this mechanism, we will be looking at homolytic bond fission. And this is when your covalent bond breaks and the two electrons in the bond are shared between the two atoms. So if you've got a covalent bond between X, both of these will be shared equally, forming your free radical. So in this case as well, remember the definition of a free radical. This is a species with one or more unpaired electrons. So let's look at this reaction then. So there's always 3 steps to this reaction. You need to remember you have an initiation step. This is where you're forming your radicals. Then you've got a propagation step. So normally propagation step will keep on going until you kill off the radicals. So you can keep reacting and reacting and reacting until all your hydrogens have been replaced, unless you terminate. So your last step is termination. Termination step is normally to kill off radicals. So this is where 2 radicals join together, so you end up with no more radicals in this reaction. So let's look at this in detail then. So let me do 2 examples. I'll do one in terms of curly arrow mechanism and one where I'm just writing the equations. So let's look at C2H6 reacting with chlorine. Obviously you need UV light to form CH3CH2Cl plus HCl. So in this case, your mechanism would involve initiation. So during initiation, you're always going to be breaking the Cl to Cl covalent bond. So remember, there's a pair of electrons there. And when you're showing me the movement of one electron in a mechanism, you have to draw your single-headed arrow. So in this case, one electron is going to go to this chlorine, the other electron is going to go to this chlorine. And this will form 2 Cl radicals. So this is homolytic bond fission. Next step would be propagation. So in this case, if we've got ethane, this will react with the chlorine radical we just made. So in this case, we have to break one of these CH bonds here. So whenever 2 single-headed arrow meet, that shows a covalent bond forming, because that's 2 electrons combining. And then I'm going to send this other electron here to the carbon. So this will form the radical on this carbon plus HCl, or hydrogen chloride in this case, and then you reacting again with a Cl2 to reform the Cl radical. So you've got this reacting with chlorine. So you've got one electron going there, and notice how my arrows are going from the middle of the bond. That's where your covalent bond is, your shared pair of electron is. So this will form a bond between the C and the Cl, and then a Cl radical. So you're reforming the Cl radical. So we normally say it's regenerated. So you're reacting it there and you're reforming it there. So it could act as a catalyst in this case. So now these steps would keep on going until you substitute every single hydrogen. So you could substitute this hydrogen, this hydrogen, this hydrogen, this hydrogen, this hydrogen. But we have to actually force this reaction to stop whenever we formed our desired product. So in this case, the question was only asking for one substitution, a monosubstitution. So now our termination step involves killing off all the radicals. So every single radical we've produced, so Cl radical and this radical over here, the one with the ethyl group, we need to terminate. So we need to react them with each other. So first available termination step to kill off the radicals would be two Cl's radicals reacting together. So in this case, you would have chlorine forming again. So you're forming Cl2. So sometimes in past paper questions, they can ask you, give the termination step that produces an inorganic product. So remember, this would be your inorganic product. Then they could say, give the termination step that produces an organic product. So these would be the next two now. So you could have this reacting with your chlorine radical. To form the actual product that you wanted to form. Or you can have two of these reacting together to form a larger alkane. So this would form butane. So these two would be involving organic products. So like I said, read the question carefully and see which termination step they are asking for. If they don't specify a termination step, I would say the first one would be the easiest one to give them. So this was the mechanism, curly arrow mechanism, and now I'm going to do an example where we have just the equations. So let's keep it simple and let's do just methane plus, let's say, bromine with UV light. This will give you CH2Br2, let's do, plus 2HBr. So in this case then we have again initiation, which is just the bromine homolytic bond fission to form two bromine radicals. Then we have propagation. So in this case, since it's not a monosubstituted product, you have to do two steps. So the propagation steps always goes in twos. So you would have CH4 plus the bromine radical to form this. So remember, the radical goes on the C, so be careful where you're drawing it. Plus HBr, and then the CH3 plus Br2 forms CH3Br plus Br radical. Then we have to substitute once again. So CH3Br plus Br radical is going to remove another H. So CH2 radical there, Br plus HBr. And then CH2 Br plus Br2, reforming the bromine radical. And you're forming your product now. There. And now termination. You can have the easy one where you have just bromine radical reacting with another bromine radical to form Br2. Or you could have any other radicals that we have here. So we've got different ones. So you have this, this, and this reacting with each other. So in this case, we could have bromine radical with the CH3 radical to form CH3Br, or you could have bromine radical with CH2Br radical to form CH2Br2, or you could have two lots of CH3s to form C2H6, or you could have CH3 radical with the CH2Br to form C2H5Br, or you could have two of these. To form C2H4Br2. So I hope this was helpful. Thank you very much for watching.